Welcome back. My name is Bob and I'm a tutor at Raritan Valley Community College's Academic Support Center. This is the fourth module of Session 1 on Calculator Basics. In the first two modules, we covered the layout of the calculator, the home screen, the ability to edit a calculation, negative versus subtraction, syntax errors and how to fix them, and the order of operations, or PEMDAS. We looked at calculator mode, including scientific notation and floating and fixed decimal points, and calculator functions. In the third module, we covered the basics of graphs. So we're going to move on and cover a little bit more detail on graphs in this module. Specifically, we're going to look at linear equations, both one linear equation and two linear equations. We're going to look at a quadratic equation, the absolute value, the greatest integer equation, a piecewise function, and we're also going to reinforce several of the concepts that we introduced in Graphing Basics in Module 3. Let's try a calculation. We're going to try graphing the equation y equals 3x plus 2. First thing we need to do is get to the graphing screen, the y equals screen, and we press the y equals button, and then we enter in the equation 3 times, then we're going to hit the x, t, theta, and n key to get the x, plus 2, enter. Now that we've got the equation entered, let's graph it. And we can do that by pressing the graph key in the top right-hand corner. And you can see the graph appears. If your graph didn't appear, it could be that the window's not set correctly. The best way to do that for this equation is hit zoom, and then we're going down to a standard window, which is option number 6. So we'll scroll down to number 6 and press enter, and now your graph should be in the frame. Now suppose we wanted to calculate the value of y when x equals 2. There's many ways that we could do it. The first is using the Calc function. And we get to the Calc function by pressing second and then Calc on the top row. And you can see there are a lot of options for the calculate function. We're going to use the first function, value, because we're going to try and calculate the value of the function when x equals 2. Since the 1 is highlighted, we just press enter. And you can see in the lower left-hand corner of the screen that we have x equals. We're just going to put in 2 and then press enter, and you can see the equation comes out when x equals 2, y equals 8. Notice on the top left-hand side is the actual equation that we're calculating. Now let's try a different way. First, we're going to go to the home screen, and remember we can get to the home screen by pressing second quit. Now we're going to try a new function, the vars function. So we press the vars key, and you can see that there are lots of options there. On the top there is a left-hand option, which is vars, and a right-hand option, which is yvars. We're going to scroll over to the right-hand option, which says yvars, and notice that function is already highlighted. We'll press enter, and you can see y1, y2, etc. listed there. Since our function was in y1, we're just going to press enter, and y1 shows up on the home screen. Now we've hit parentheses, the number 2, in a closing parentheses, and hit enter, and you can see that y1 of 2 is 8. In f of x notation, this is the same of f of 2 equals 8, a very similar kind of operation. Now there's still another way that we can see the value of the function. Let's try that. We're going to look at a table of numbers. So we're going to go to second table, and you can see that a table shows up that has numbers in it. Well, there is even a couple of options under the tables function as well. This option that's showing right now allows us to scroll down, and we can put in any value we want, let's say 3, and hit enter, and you can see that f of 3 is 11. Suppose we had a lot of values that we wanted to calculate and they were all sequential. Suppose we wanted to calculate when x equals 0, 1, 2, 3, etc. We can set that up in the calculator. We'll go to the table set function by pressing second table set, and you can see that there's a table start function which says that we're going to start at 0. You can see a triangle table function, and that's how much we want to step up by or change by. And so in this case we want to clear the 0.5 and we'll make it step up by 1s. And then you can see that the independent variable, or x variable in this case, is set for ask. We're going to make it automatic. So we'll put the cursor over auto, we'll hit enter, and you can see auto is now flashing. And now we'll go back to the table. Remember, we got there by pressing second table. Notice now that the table is filled in with 0, 1, 2, 3, 4, 5, and 6 for the x values, and the appropriate y1 values are shown on the right. Let's try that on your own. Welcome back. Now suppose we wanted to graph two equations at the same time. Let's go back to the y equals screen, and we'll scroll down to y2, and we'll put in a new equation, y equals minus x minus 1. We're going to load in minus, and remember we're using the opposite of sign here, not the negative sign, or not the minus sign, xt theta and n, subtraction sign 1. And now we're going to hit the graph key. And you can see our original graph, and there's the second line coming through. Suppose we wanted to find out where those two lines intersected. Well, we can do that using one of the special functions under that calculation key. We're going to hit second and then calc, and we want to find the point where they intersect. Notice that's option 5 down on the screen. Rather than scrolling down to option 5, we can actually hit the button 5 and we'll jump right to the intersection screen. And notice that we're being asked a question. It's asking, are we on the first curve, question mark? And the answer to that is, yes we are, so we'll hit enter. And notice that the cursors jump down to the other line and it says, are we on the second curve? And the answer is, yes we are, so we'll hit enter. And now it's asking for a guess. The guess really doesn't matter too much. All it does is speed up the calculation if you're pretty close. So we're going to move over a little bit. We'll use that as our guess. And we'll hit enter again. And it says that the intersection of those two lines occur when x equals minus 0.75 and y equals minus 0.25. Which is kind of neat if you're trying to find out where two things are intersecting. There's one other thing that we ought to take a look at while we're looking at these two graphs. For those of you who had algebra here at RVCC and took the mods, or for those of you who had algebra in high school for that matter, you can remember how difficult it was to deal with inequalities. One of the neat things that you can do with a calculator is look at some of these inequalities. So let's go back to the y equals screen, and we're on the first equation. Suppose we wanted y greater than or equal to 3 times x plus 2. The way we can do that is we scroll over to the right beyond the equal sign, all the way over to that bar, and now every time we hit enter, that bar will change shape. Notice we got a heavy bar when I hit it the first time, and now we've got the area above the curve, or the area that's greater than the curve. Now suppose for the second equation we wanted the area below the curve. We could scroll down, we would enter for the heavy line, enter for a greater than, enter for a third time, and we get less than. And now when we hit graph, and notice here's the first equation coming along, and you can see everything greater than that. And here's the second equation coming along, and you can see the crosshatched area on the left is where the two intersect, and that's where both conditions are met. That we are greater than the first equation and less than the second equation. It's kind of a neat way to figure out what's going on with inequalities. Let's try that on your own. Welcome back. Now let's try some different equations. The first one we're going to try is the quadratic equation. So let's go back to the y equals screen, and we're going to clear that first equation, and move down and clear the second equation, and we're back to nothing on the y equals screen. And we'll go back up, and let's try the equation x squared plus x minus 6, and we want to solve that equation. Well, we hit the xt theta and n key. Squared, we can either use up arrow 2, but I'm going to use the squared key, plus xt theta and n again, subtraction 6, and now we can graph that. And you can see we get our friend the parabola. Now there's a couple of things about the parabola that we'd like to find. One is, where does it cross the x-axis? If you remember from your pre-calc days, where we cross the x-axis is called the zero of the function. So we're going to go up and hit calc, second calc, and we're going to go to option number 2, and I hit the number 2 for the zeros, and it asks us now a question. Left bound. That means, are we on the left side of the 0 that we want to calculate? Well, let's look at that 0 over on the left side. So we're going to hit the scroll left button, and we're going to continue to scroll left until we're on the left side of the 0. And then we hit enter, and now we're asked a question, are we on the right side of the 0? And the answer is no, so we're going to scroll to the right using the right scroll button and hit enter again. Notice that the area that we've surrounded there is captured by those 2 arrows up top, and it says a guess. I'm not even going to guess this time, I'm just going to press enter. And you can see that the 0 occurs when x equals -3 and y equals 0. To calculate the other 0, we'd do exactly the same thing. Let's do it. We're going to hit second calc. We want to hit the value 0. This time I'm going to scroll down to 0 and press enter. It's asking, are we on the left side of it? We're going to use the left key, or the right-hand key, to move over a little bit to the right. And yes, we're on the left-hand side of it, so we'll press enter. And now we're going to move further to the right, so we're on the right-hand side of the 0. And we'll hit enter again. It's asking for a guess. Let's see if we can scroll left and get a little closer. That's pretty close. We'll hit enter. And you can see that the other 0 occurs when x equals 2, y equals 0. Those are the 2 x-intercepts. There's one other interesting thing about a parabola, and that's the vertex. How can we find the vertex on this? Well, on a parabola, the vertex and the minimum are the same point. So in this case, we'll hit second calc again. This time we want to find a minimum, so we'll scroll down to number 3 and hit enter. And it's asking again, are we on the left side of the minimum or the vertex? No, we're not, so we're going to scroll to the left until we're on the left side. Yeah, that's pretty good. We'll hit enter. Are we on the right side? No, we're not, so we're going to scroll to the right side. Can we just need to be anywhere to the right? We'll hit enter again. It's asking for a guess. We'll get a little closer and hit enter. And there you can see the vertex comes up where the minimum is at the value -0.49999 and y equals -6.25. That's the vertex. The interesting thing is, notice that the calculator only approximates these things, so the vertex is really, in this case, at -0.5. There'll be lots of cases where the calculator gets very close, but doesn't get the exact value that you'd expect. But the decimal point should be off only in the far right-hand digits of the calculation. Now, of course, we could have done that calculation the old way. You remember doing quadratic equations using -b plus or minus the square root of b squared minus 4ac? We could do that by going to the home screen. So we'll hit second quit. And in this case, our a was 1, our b was 1, our c is -6. So we would start out with the opposite of 1. We'll do the first option, plus, then the square root of, second, square root of b squared, well that's 1 squared, minus 4 times a, which is 1, times c, which is 6, which is -6. And notice that we can put the opposite of sign right next to the asterisk, it doesn't matter. Close the parentheses, all right, divided by, and then we want 2 times 1, and we hit the answer. We get 1.5. Well, that's not the answer we expected. Remember PEMDAS. We're going to go back and put parentheses back in the equation where we need it. We need that whole numerator in parentheses. So we're going to bring the equation back. Remember, second entry. We're going back to the very beginning. We're going to insert, second insert, a parentheses. We're going to go all the way over to the parentheses on the right. We're going to close that parentheses on the right. Again, second insert, and we're going to close that parentheses. And the denominator needs parentheses as well. We're going to move over to the 2, second insert, and we put in a parentheses, and then we scroll to the end. We don't need an insert key here, we'll just hit parentheses, and we hit enter, and you can see that the value is 2, just as we got using the second calc way. Isn't second calc a lot easier? We could do the same thing with the other 0 or the other intercept, but in this case I'm going to leave that as an exercise for you. Why don't we pause here and let you try some of these calculations. Welcome back. Let's try now an absolute value equation. The calculator is really helpful in solving absolute value equations. Let's try the equation y equals the absolute value of 3 minus x plus 2. Let's go to the y equals screen, and we'll clear that quadratic that we had there by pressing the clear button. And now we want the absolute value function. Well, if you look on your calculator, there's a math key. So we'll hit math, and then we're going to scroll to the right over numbers. And you can see the ABS, or absolute value function, is the first function that shows up. We're going to hit number 1. And you can see that we have the absolute value of, we want 3 minus xt theta and n again. We're going to close the parentheses for the absolute value function, plus 2. Now we can graph the function by pressing the graph key, and we get the traditional absolute value function. You can see there's no x-intercepts on this because we didn't hit the x-axis, but there is a y-intercept. Suppose we wanted to find the y-intercept of this. Well, there is no y-intercept key. You have to remember in math that the y-intercept is really when the value of x is equal to 0. So we can find the y-intercept by going second calc, pressing the value function, and loading in 0. We'll hit enter, and you can see the y-intercept is when x equals 0, y equals 5. While the calculator can do many functions for you, you still have to remember the math terminology. And for things like y-intercepts, remember that that means that's where x equals 0. Why don't you try an absolute value function on your own? Welcome back. Now let's look at a different function. This is a little bit more esoteric. We don't see it a lot in pre-calculus, although it is shown usually in the first chapter just as a different type of function. We're going to look at the greatest integer function. All right, the greatest integer function can be gotten to just the same way we got to the absolute value function. Suppose we just wanted y is the greatest integer function of x. We would press the y equals key. We'll clear that old equation. And now we're going to use the math key again. And the greatest integer function is called the integer function. We're going to scroll over to numbers, and we're going down to number 5, the integer portion. And that gets us the integer portion of the number. And now we're just going to put in xt theta and n again with a closing parentheses, and we'll hit the graph key, and we can see the greatest integer function as we would expect to see it in some of our pre-calc texts. Why don't you try the greatest integer function? We'll pause now. There's another type of function that we see early on in the pre-calc class, and that's a piecewise function. Let's take a look at how we could graph a piecewise function. We're going to back to the y equals screen, and we're going to clear away the equation that we had. And now let's look at an equation that's defined as follows. Suppose f of x was equal to x plus 3 when x was less than or equal to 0, was equal to 3 when x was between 0 and 2, and it was equal to 2x minus 1 when x was greater than 2. Could we graph that all as one function? Well, it turns out we can, but it requires a lot of work. So let's try it. We're going to start, and we're going to put the equation in parentheses. So we're going to open with the parentheses, and the first part of the equation was x plus 3. So we're going to enter x using xt theta and n plus 3 and a closing parentheses. And now we want to put the condition next to it. So we're going to put an opening parentheses, and we're going to go to something called a test. And we want to test to make sure that x is less than or equal to 0. So we're going to put in xt theta and n. We're going to go second test, which is on the math key. We want less than or equal to, which is number 6. We scroll down and press enter, and we said less than or equal to 0. And then we're going to close that parentheses. Now we're going to add the next function. And the next function said it was just the value 3 when x was between 0 and 2. So we're going to put in parentheses, 3 parentheses, and we're going to put in the condition, parentheses, and we have to split this into two different conditions now. So we're going to have the first one is x is greater than 0, xt theta n. Second test is greater than is number 3, we'll hit the 3, 0, okay, and, well, we're going to go back to the test, second test, we're going over to the logic thing, and we want and, x, t theta n, is less than or equal to, second test, less than or equal to is number 6, and 2 is the final portion of that test with a closing parentheses. And now we're going to add the last function, plus, in parentheses, 2 xt theta and n, minus 1, closing parentheses, and the condition for this, opening parentheses, xt theta and n, second test, is greater than 2, closing parentheses, and now we graph that function. And we get this goofy looking function that's got a little step in the middle of it. So you can see by piecing functions together and using the test in there, we can put conditions on the functions and piece 3 functions together. Why don't you try that? It's a little difficult. We'll give you some extra time as we pause here. Welcome back. Let's take a look at that for just a second and see why this function worked. I'm going back to the y equals screen, and the reason this function worked is something called Boolean Functions. It's not the name that you need to memorize, but it is interesting to know. As you can see, we had the first part of the equation, the x plus 3, times a function which was x is less than 0. The Boolean question here gives us a 0 if it's false and a 1 if it's true. So it took that first equation and multiplied it by 1 whenever x was less than 0, and 0 when it was not true. The same thing with the second part, the 3. It multiplied it by a 0 when x was less than 0 or greater than 2, and by a 1 when it met both conditions that x was greater than 0 and x was less than or equal to 2. And the third part we added in was the 2x minus 1, and it gave us a 0 when x was less than or equal to 2, and a 1 when x was greater than 0. By adding those functions together, we were able to create the piecewise function. Again, this is not something that you necessarily need to know for using the calculator, and you won't find this problem a lot, but it's an interesting little fact. Well, we're just about done this module. In fact, we're almost done the first session. But before we go, I'd like to show you just a couple of other functions that the calculator has that can come in handy sometimes. Let's get to the home screen. We'll hit second quit. The first of these is, suppose we were trying to find out what factor two numbers had in common. Let's try the numbers 25 and 35. In this case, the function that gets us the common factors is called GCD, or greatest common divisor. We can get there by hitting Math, scrolling over to Number, and you see after number 7 there's an arrow as opposed to a colon. That means there's more functions. We're going to scroll down past 7, down to 8, and there's the GCD, or greatest common divisor function. We'll hit Enter, and the greatest common divisor of 25, comma, 35, closing parentheses, Enter, is 5. And that's what you'd expect. Suppose you wanted to find a common denominator if you want to add two fractions. Well, you could do exactly the same thing. We would hit Math, scroll over to Number, scroll down, or we could actually scroll up to number 8, which is least common multiple, which is our common denominator if you would. Press Enter, use the same two numbers, 25, comma, 35, closing parentheses, and hit Enter, and we can see 175 would be our common denominator if we were adding together fractions that had 25 and 35 in the denominator. Speaking of fractions, the calculator does something really neat with fractions as well. Suppose we wanted to add 1/2 and 1/3. Well, let's go ahead and do it. 1 divided by 2 plus 1 divided by 3, and hit Enter, and we get 8.3333 and a bunch of 3's. Suppose I wanted to know what fraction that was. Could hit Math again, and you can see that the very first function there is called fraction. We'll hit Enter, and it has answer fraction. We hit Enter again, and we can see that is 5/6. So we can convert a decimal to a fraction using that fraction function. We can go backwards as well. Suppose we wanted to convert 5/6 to a decimal. Well, we could do 5 divided by 6 and hit Enter, and we get back. Or if we had a fraction already there, we could hit Answer, and we use second answer. And then we'll go to the Math key again, and option number 2 is decimal. Hit Enter, and hit Enter again, and you can see that we can convert 5/6 to a decimal. So the function goes both ways. Well, that concludes this module. In this session, we've taken a look at the basics of the calculator. We've looked at the basics of graphing. And in this particular module, we looked at graphing a single linear equation, 2 linear equations. We looked at a quadratic equation. We looked at the absolute value equation, as well as some special functions. We've looked how we can calculate values using either the Calc value function, the y1 function, or the table function. And we've looked how we can find a minimum or a maximum, which is a vertex of a parabola. We'll move on in the next session and look at some more complex functions. This concludes this session. Current students at Raritan Valley Community College can get additional support by coming to the Academic Support Center. The Academic Support Center is open during most school hours, and you can check the hours by going to the web, www.raritanval.edu, and looking under the tab Current Students, and under Academic Resources, look for the Academic Support Center. The Academic Support Center offers a wide variety of tutoring assistance from math and English to the sciences and various humanity courses. The Academic Support Center is there to help you.